so we are looking at number 10 from the circles vocabulary. Okay, looking at number 10. So first, we need to draw a picture of the situation. We are given circle S. When you're given a circle, sorry, my screen wasn't working and I couldn't see where I drew. When you're given a circle and it's named circle S, that automatically means that S is the center of the circle. And we're given that point P lies outside S. So you can draw a point P wherever you want, but make sure it is in the exterior of the circle. Okay, how many lines have to pass through P? Now, it is a line. A line goes on forever, so don't just cut it off and make it stop inside your circle. It will go on forever. How many lines through P are tangent to S? So you go to your handy-dandy vocab sheet, because you might not have memorized them yet, and you look up what it means to be tangent. It says a tangent line intersects a circle in a single point. That means it intersects one time. So if I want to be a line, go through P and hit my circle one time, pretend like that hit the circle. There's an example of a tangent line. Now, when you're doing these, how many? You try to draw as many as you can. Can you draw any more lines through P that are tangent to S? There's our drum line. Okay. Yes, we can. Okay, where else? Where else? It is a party outside. So if I drew this one, I had some students in class, they stopped it there. I'm like, well, no, that wouldn't be a tangent line. So no, there is only two. You kind of go above the circle and below. You hit it from one side, you hit it from the other side, and you're done. It's over. So the answer is 2 there. Number 12. How many? Okay, given. We got to do our given. Given, Q lies inside in the interior of circle S. You can put Q wherever you want. It doesn't matter. The answer will be the same no matter where you put it. How many lines through Q are tangent to S? So if I have to pass through Q, well, first of all, let's ask yourself this. Does a tangent line ever pass through the interior of a circle? Always, sometimes, or never. Can't. Tangent line cannot go through the interior because then it would intersect the circle twice. So if Q's in the interior and I need to go through Q, that's impossible. 0 lines go through Q and are tangent to the circle. Number 18. Use always, sometimes, or never to complete the statement about. Some people don't read what the statement is even about. It's about 2 concentric circles. So I'm going to draw 2 circles that have the same center. That's what these statements are about. There always, sometimes, or never exists a line that's tangent to one circle and secant to the other. So I want to be tangent to one and secant to the other. There always, sometimes, or never exists one. So it's like asking, can I do it? Can I be tangent to one and secant to the other? So this one, pretend like I hit that, is just tangent to one. It's not secant to anything. What about this one? I am tangent to my smaller circle, and I am secant to my larger circle because I'm intersecting the larger circle twice and intersecting the smaller circle once. Sorry, I really didn't actually answer the question. It is always. There always exists one. I could never draw concentric circles. Draw me a pair of concentric circles. I'll draw a different pair than I just did. Does there exist a line that's tangent to one and secant to the other? Yeah, it still exists. I can't think of a single time when I would have concentric circles and I couldn't draw one tangent to one and secant to the other. I could always draw one. There always exists one. I'm not saying every line is tangent to one and secant to the other. I'm saying there always exists a line. Number 5, we learned a theorem. We learned that if a quadrilateral is inscribed in a circle, the opposite angles are supplementary. Not congruent, but supplementary. So, I'm just going to go ahead and fill in the angles. We might need them, we might not need them. That one's obviously 100. Let's look at inscribed angles. Inscribed angles are half of their intercepted arc. The opposite of halving something is doubling something. So 80 doubled is 160. And I know I've used up 70 degrees of that 160. So 90. Done, done, done. Okay, we're looking at angles 7, 8, and 9. I have put the given information on the picture so far. Let's look at angle 7 first. When in doubt, when you don't know how to start, first name that angle. What is the vocab word for angle 7? That is an, I'll give you a hint by putting an N on the A. That's an inscribed angle. An inscribed angle is half of its intercepted arc. We don't know its intercepted arc, but we do know that AD is a diameter. And a diameter means that arc AED is a semicircle. Arc AED is a semicircle. So we're going to do 180 minus 120. We're going to get 60 degrees for arc ED. Inscribed angle is half its arc. All right, angle 8. Angle 8. When in doubt, say the vocab word. What type of angle is angle 8? Central angle. Central angles equal their arc. It doesn't get much easier than that. They literally equal the same degree as the arc that they are intercepting. Yeah, it looks 90. No, you don't put 90 just because it looks 90. And number 9 is a linear pair to number 8.